All right, here we are, part three. Just finished up confidence intervals, right? So, moving on to our third and final piece of this, which is significance tests, right? Now, before we broke it up into two different chapters, but since we already know confidence intervals for the most part, we already know significance tests. We're really just looking at it as a combination of the two, right? And we can put them all together. So this is your significance tests for P1 minus P2. So again, we're looking at it as two proportions, a test on two proportions, and seeing if there is a true difference or not. Conditions, they're going to stay the same. I would just say the conditions. We could even write conditions and then put C confidence interval conditions, because it's the same thing, right? You still have your same three conditions: two independent random samples, or two groups in a randomized experiment. The 10% if you're doing it without replacement, and then your large counts. So as far as that goes, we do have a little bit of it, and then with the a little bit it's different with the significance tests is your hypotheses, right? Those are going to change a little bit, not too much, right? But our example here, right, part A, that's why I did this example, was because it talks about stating the appropriate hypotheses and defining the parameters of interest, right? So the parameters, right, that we've already discussed before, and that would have been the P1, right, and we would say P2. And as far as that goes, you've got P1 would be the proportion, or the true proportion, I should say, right? So true proportion of 18 to 29-year-olds who use Instagram. And then this would be the true proportion of 30 to 49-year-olds who use Instagram, right? So as long as I line them up that way, I'm okay using the quotes there. And then the hypotheses, right? So we have HO, and then we're going to have HA, right? So if you think back, HO is always a statement of no change or no difference. Well, that means that if I did these two, P1 minus P2, that difference would be zero. Our assumption is that they're zero. It hasn't changed. They're not any different. So that's what we're doing. So before it was just one. I can also write this as P1 equals P2, right? You don't need both. You just write one or the other, whatever one you feel more comfortable using. And for HA, you're trying to show, do these data provide convincing evidence that a greater proportion of, so you're trying to show that P1 is higher. So that means P1 minus P2 should be greater than 0, or you can write P1 is greater than P2. All right, again, you don't need both of these. You just need to put one or the other, whatever one you feel more comfortable. That's really the only difference with a significance test that we haven't seen before. All right, so it's still the same layout, the same whole phantoms thing. All right, again, I don't have to go through all of that again, but if you don't have it all, there's no possible way to get full credit. All right, so make sure all of that's in there. Part B, checking the conditions. All right, so it looks like you took separate random sample. So you took independent, and I'm okay saying independent random samples because it does say that you took separate samples of 269 and what was it, 401. All right, so that was your random that's checked off. 10%, there's more than 2,690 18 to 29-year-olds, right, on Instagram. and there's more than 4,010 30 to 49-year-olds on Instagram. Okay, and then our NPs and NQs are successes and failures for each, right? So that's our large counts. All right, we're going to take, let's see, 31% of them used Instagram. So we're going to have to figure these ones out. So we have 269 times 0.59269 times 0.41, and then 401 times 0.31, 401 times 0.69. Find out what all of those are. And this one was 158.71. You've got 110.29, right? You've got 124.31, and the last would be 276.69, right? So all greater than or equal to 10, so that checks out also. All right, so all three of them check out, so you are good to go and move on. All right, so there's kind of the start, right? Using the conditions, a little bit new with the hypotheses, right? It's a little bit different than one sample. Also, the formula, right, for your statistic. It is a Z statistic, just like before. Right, you're going to take p hat 1. This is your estimate minus p hat 2. Still following that same format we said before. Minus p1 minus p2. Right, so we're assuming that this is 0. Right, so really this doesn't even really matter because we're assuming that's 0. I would say 9.5 times out of 10. Right, you would know if that's not a 0. But your null, if there's no difference in the two proportions, that's going to be a 0. And then this is where things are going to change, right? Star this, right? This is where things are different because it's not the same as what we did here where we separate p hat 1 and p hat 2, right? This is different. So this is where you just take, I call p bar over n1 plus p bar times 1 minus p bar over n2. And p bar is the combined x's out of the combined n's, right? So this is kind of like the pooled, they call it a pooled proportion, right? Because if the assumption is true, if these are in fact the same, these two independent samples, it's like they're coming from the same population. Okay, so it's you can just put them together and make one giant. So that'll be p bar. You might see it as p bar. You might see it as p sub c. I think our book might even just call it p hat, right? If it's a 2 proportion. I don't really like p hat because that's like what it was before. So I would try to stay away from p hat. Try to find other notation to use for it. All right, so as far as that goes, I've got 2 more examples for us, and then we're done with this section, right? So I've got one to kind of break down that middle part that's a little bit different with the statistic and whatnot, and then one full-blown significance test so you have a chance to see what that looks like. All right, so A. This is based off of the data we just did or the conditions we just did in the last one with the 18 to 29-year-olds and the 30 to 49-year-olds. So explain why the sample results give some evidence for the alternative, right? So if you remember, the null was P1 minus P2 was equal to 0, and we were trying to show that P1 minus P2 was greater than 0. Okay, so why do we have evidence for the alternative? Well, if we found p hat 1 minus p hat 2. If we took the difference in our two sample proportions, we end up with 5.9 minus 0.31. That's going to leave us with 0.28, right? Which that's obviously some evidence because 0.28 is larger than 0, right? So there's at least some evidence. It's just, is that enough to say it's significant? So the standardized test statistic. All right, so I'm going to take 0.59 minus 0.31, all right, minus my 0. That's coming from the null. That's why I like writing my null and alternative this way, because whatever this value is, that's what you're subtracting by. Same idea as we were doing in chapter 9. Right, but now this is where we have to combine, right? So that p bar is where we combine things, and this is going to end up being the yes. So it would be the total yeses, right? So it would be 159 plus 124 over 269 plus 401. Which is going to be 0.422. All right. If you do not have that and you use p hat 1 and p hat 2, you cannot get full credit. All right. This is the only time it changes because it's a significance test and you're making an assumption that they are both the same population. All right. That's the assumption that there is no difference. The reason we can't do it with a confidence interval, or we shouldn't do it with a confidence interval, is because we don't know anything about the two populations. We're just trying to find an estimate of the difference in the two. All right. So this would be 0.422. This would be 578 over 269. And then if you're like me, you're always going to have to extend this because that denominator gets to be huge. So that'll be the same numerator in both, but with two different denominators, right? So the statistic turns out to be 7.20. All right. So you read that correctly, right? So the p-value for 7.20, p-value is going to be 0. And part C, what conclusion would you make? Well, 0 is going to be less than 0.05, which I think is our, 0.05. So we would reject HO, and we would say that we have convincing evidence that a greater proportion of 18 to 29-year-olds use Instagram versus 30 to 49-year-olds. All right. So we've kind of broken this whole thing down into two different parts. This is the whole second half. Just showed you one with the whole first half, right? So I'm going to actually put this in its own part, but part number 3, I'm going to run through a total test that you can see everything top to bottom of what you would need to do.